Hi everybody. Just thought I'd give you a brief rundown of how to do the implicant chart where you can find a reduction. Here we have an obvious reduction where B looks like it's equal to C, and we can remove B from the equation. But what we'd like to do is see if we can use the implicant chart to do our optimization of the state machine, starting with the second row, B, C, D. We number vertically. Then starting with the first row, we number until the second to last row. A, B, C, we number horizontally. Then we build our lower triangular matrix. And then we proceed to examine trivial eliminations. We can see that there are some outputs which are different from other outputs. So A must be different from D. B must be different from D. C must be different from D. Moreover, when we do our row-wise comparisons between A and B, we can see A and B are equivalent if A and D are equivalent, but we see they're not, and therefore these cannot be equivalent, right? Because AD has already been eliminated. So then we go A to C. AC will be equivalent if AD is equivalent, but we know they're not, so that can be eliminated. And then we go B to C. BC is equivalent if D is equal to D, and it is. It's also equivalent if C is equal to C, if it is. Therefore, B is equal to C. And so now we have an equivalent that basically says row B is equivalent to row C. And you could have done that with row matching, but I like to try and come up with a simple first example for the implicant chart. Once you determine that B is equal to C, you can cross out B and write in C everywhere you see B. Let's see if we can do that. Let's eliminate C. B is equal to C. So what does that tell me? If I have a reference to C over here in B, I don't need it. I can just put in B. And because of that, I have a reduced finite state machine. And that gives us an equivalent machine, one that's simpler for us to implement. Hope you liked my little presentation. Thank you.